find the composite itself, that's not too bad. It's finding the domain later on. So guys, I have one to try with you to move back into what we were doing. And hang on, hang on. Here it is. Given f of x is equal to x over x plus 1. G of x is equal to 2 over x subtract 3. Find the composite. Now guys, we'll find mine in that direction. And then find the domain of that composite. That's what it's all about. Okay, now I'm using the same color here, black marker, since it's showing up so well tonight. So find that composite, F circle G, and then find the domain of that composite. Guys, a little reminder, F circle G means, of course, F of G of X. We discussed that earlier. Which means F of, in my case, G of X was given to me as 2 over X minus 3. Let me go ahead and just make a replacement there. That's my G of X. That's given to me. And now to finish this up, it says take F of that. Now this is where it might get demanding. It says now go to your F function and replace all those X's by 2 over X minus 3. And if I do it here again, it's going to look like that. So up here, replaced all those X's by 2 over X minus 3, which looks strange. And then we'll be asked to simplify that, clean it up. Guys, to clean this up, I'm going to do it fairly quickly. The numerator is good, nothing to be done there. Denominator, I need to combine those two in the denominator with the common denominator of X subtract 3. Looks like. And if we got all that, make sure guys we got everything copied down correctly. Everything's good so far? Yeah. Okay. Now if I put this together, guys, that's like saying 2 over X subtract 3. If I want a common denominator, why not think of that 1 as just X subtract 3 over X subtract 3? That's still 1. And now those two terms have the same denominator, so put them together and add them up. And when I put this together, I think it's X subtract 1, isn't it?
X minus 1, yeah.
Please tell me, so far so good.
Yeah.
Okay. Now if you want to clean this up, lots of ways to do it. I think many students at this point in their math would realize that these two will cancel, which is nice. That leaves me this for the composite. I did that so quickly. Let's hope there's not a mistake. Woo! Now I'm going to go back, and it's not a complete check. I'm going to do something here. Now suppose on the side here, I should ask you to find F circle G. I'm going to throw it in a number. I said X here. Let's throw it in some number like 5. In other words, find F of G of 5. Just out of curiosity. A little practice. Find G of 5. Supposed to go to the G function and put a 5 in. So guys, what is G of 5 if I go to 2 over X minus 3 and put a 5 in for the X? 1. Right, it is 1. It's 2 over 2, which is going to be a 1. So this says now you're going to take F of 1, and take F of 1, that takes you back to the F function. Thank you, 1/2. Now I was putting a 5 in there. Now suppose I'd placed a 5 here.
Yeah, I've been...
Hang on, listen. Suppose I placed a 5 here. Would I end up with 2 over 4?
So it's 1/2.
Is that 1/2 again? So you could actually try, when you finish up and think you have the composite, try a number, take it through, and then take it to your answer and see if you get the same answer, and that makes you feel better. Say, oh my goodness, I see it does check here, at least for 5, okay? Now does it check for 6? I didn't try 6. Does it check for 3.5, Professor? I didn't try 3.5. I just tried one number. So it's supposed to show it checks for all numbers. Wow. So that's going on there. Now, here's the interesting part. Let me try a different marker. Let's go back to the original functions. the next Wednesday, I will be asking you also to list on the side here, the domain of the originals. These, the domain of the f function, the domain of the g function. Guys, tell me right quickly. Domain of the f function, x cannot be -1. Go down to my g function, x cannot be 3. Now the question is, what's the domain on this? This is my composite. That's what they want. They want really the domain on after you do the composite with the two functions. I realize the two functions have separate domains. Now what's the domain after you put them together? I'd say with the way the answer looks, x cannot be 1. Is that true? Yeah. Now, here's the catch. On these composites, you've got to be careful with. I would accept that, but you got to keep in mind how that was formed. That answer was formed by me placing, I think it was this. I placed this, I think it was, into the F. If there's something wrong with this, I could not have done that. What would have messed me up here to begin with that would have said, no, you can't do this, Professor? What is the domain here? X cannot be what? 3. If it were a 3, I could not have done all this. So that means you had better add also, x cannot be a 1, comma, 3. You have to include that also. Or you could not have done what I did. Okay, so there's two numbers there. David.
So to summarize, basically, the composite function inherits the function that you're plugging into the main one.
Yes.
So, but the main function's domain is technically irrelevant. So like
It's
negative.
sort of set. Yeah.
So -1's.
No,
whatever.
No, so what you're putting in,
Yeah.
like in my case, I was putting in what, g of x. I had to pay attention to the domain on g of x, because if g of x had a restriction, it does in this case 3, I could not do the problem. So you have to point that out at the end. So that's my complete domain on that composite. Guys, I would point that out for a little quick recap. By the way, now, I did f circle g. I don't have the time tonight to do others. We did others before, like g circle f backwards, or f circle f, g circle g, with all those composites, and then the same questions. After you find them, just give me the complete domain. But we did so those in the class already. With that said, part 2. Beautiful recap there. We also discussed this. An inverse function, and we know the notation, f superscript -1 of x. Now, I'm going to put right above the word inverse, because I am going to recap here. I'm going to use this. We're interchanging. We're interchanging coordinates. So all it comes down to for an inverse, you're interchanging coordinates. But sometimes there's an issue if you start interchanging coordinates. So guys, I'm going to do this for you before I jump into some examples. Suppose I have set A, and I have set A to contain, I think I brought in some ordered pairs here. These ordered pairs, -2, 5, -1, 2, 0, 1, 2, 5. Would everyone agree that represents a function? Based on what you know a function is. Most students will look through the order of pairs and see if there's an x repeating, Professor, it's not a function. Do I have an x repeating? No, so this is a function. Now I'd like to find its inverse, which is, I'm gonna call it a superscript -1. You say, wait, Professor, you're saying just do this. Go through and interchange the coordinates. That's all you do. Now, can someone tell me the issue on this? On this particular one? Please tell me.
A repetition
There's a repetition where?
for 5 negative 2 and 5 of 2.
You can't have that. If you do, it's not a function. And we're talking about inverse function. So this thing's not a function. Therefore, I can say there is no inverse for it. I tried. I tried to interchange, and it didn't quite work. Now, how will you know that your function is one-to-one? I'm using my phrase too quickly. How will you know that your function is okay to find an inverse without sitting there and saying, oh my goodness, on the quiz next Wednesday, he's going to ask me to find the inverse, and he gave me a function that has no inverse, like this one. You stop. You say, there is none, Professor. Now, how am I going to do it? Lots of ways. Here's some examples. Let's say Wednesday, you're looking at this. I give you function x squared plus 4. I ask you to find its inverse. All right, like that. Now, can anyone tell me, should I go ahead and attempt it? Or should I say, based on my math, don't even attempt it, Professor, it has no inverse? Now, if you say, it looks pretty good, Professor, I think there is an answer, there's an inverse, then you're going to do this on the side here. If. I'll see you after class. Yeah, if you say, oh, no, Professor, it's okay, then you're going to do this, interchange, x here, y here, that's what it means, interchange, and solve for y. And you have the inverse. That's how easy an inverse is. You interchange and solve for y. But can someone tell me, based on what we were discussing here, why might it be, I'm going to say it, why might it be, Professor, don't mess with this function, it has no inverse? I'll see some hands going up. Yes?
So f of x at the moment it's x squared plus 4, that's a parabola, and if you visually see it on a graph, the parabola inverse will not be a function because
Now, she tells right quickly, Professor, this is, if you want to look at a picture of it, a graph of it, this is a basic parabola shifted up, vertically shifted up 4. It's up here. We've done transformations before. She said, if you want to see a picture of it, it's right here, Professor. That's a picture of it. Now, what does that picture tell me that maybe was harder to see here? And I mentioned this on Monday. What test is that you can use if you have a graph? Not vertical tells you that's the function. Horizontal. So if you draw a horizontal line somewhere on that graph, and you have 2 points of intersection, which I do, automatically you stop. You say, this does not have an inverse. Stop, Professor, there is none. No inverse. Now why? You saw why this thing up here had no inverse. Why here? Suppose I ask you to plot, name a couple of these points for me. As I say, this is 1. I'll replace x by 1 and do the math here, I get a 5. Suppose over here I label this point as -1. What would I get if I put a -1 in here? -1 squared plus 4 gives me a what? 5. Do I have that repeating like you saw back up here in my problem somewhere something was repeating? Is that true? You have a y repeating, don't you? And if you have a y repeating, you stop. Because when you turn it around, it's going to turn into a non-function. And therefore you have no inverse. Now if you have a graph, just use the horizontal line test, and I'll tell you quickly. If you have 2 points of intersection, Professor, don't mess with it. It has no inverse. Besides that, can you give me, let me give you one more here. G of x equals, we just had an exam where we did these. That's a polynomial function. You guys love those. Could I ask you to find the inverse of that? No. It has no inverse. It would not pass the horizontal line test. Okay, would not pass the horizontal line test. Now, one more here. H of x is equal to, let's say something like, why not? A rational function. If it looked like that, would it pass the horizontal line test? Yeah. It would. You could pass the horizontal line. Up here, it was find one point of intersection. If you pass the horizontal line here, you have only one point of intersection. You'll never have two. So this thing has an inverse. That's a rational function. So that could have an inverse. The other two do not have inverses. Now though, your textbook does you a favor. The author does you a favor. And he was here on campus last year, and we asked him why he did this. And I don't know as a instructor on whether I would have done it, but he does it for you. He tells you, in essence, it has an inverse or not an inverse. Without you in your mind thinking about horizontal line test and all that. He does this. Part 3.
Because of the essence.
Something else. When he gives you the function, we'll try one here. We'll call this, and we'll have a quiz here tonight. And we'll try this one. Beautiful. I will call it f of x equal to x plus 1 over x. That's a rational function. You're being quizzed tonight on the graph of a rational function. But now, tonight, for me, for right now, I want to find this. I want to find the inverse of that rational function. Now first, I've got to think, is it possible?
Yes.
Will it pass the horizontal line test if I can visualize the graph? And you guys have the graph tonight for me. You think it's going to pass the horizontal line test if you do a visual in your mind of what that thing might look like if you go through horizontal asymptote, vertical asymptote, all that business? You think it would pass the horizontal line test?
Yeah.
Now, the description they use when it does work. If the function does work, this one did not work. Before I jump back over here, please tell me if I had A to look like this. Create something right quickly here, yeah. -2, 5. And -1, 2. 0, 1, I think I had. Suppose I'd stopped. There it is. I left out that last ordered pair. Now, would you say that should have an inverse? Can I interchange the x and the y and not run into an issue? If I do, it looks like this. Is there any issue with that? No. It's a function. Therefore, this will serve as my inverse. This is the inverse of this. I ran into no issues. I didn't run into issues like I did here. They describe this as, is your function 1 to 1? If your original function is 1 to 1, that's the description they use, it has an inverse. If it's not 1 to 1, forget it. It has no inverse. So guys wonder what that phrase 1 to 1 means? That means back here, when I pair -2 up with 5, I cannot pair -2 up with 5 again. Or I cannot use 5 again. Did I use 5 again?
Yeah.
Over here it's 2. I can't do that. That's not 1 to 1. So I cannot do it. So watch out for that phrase. 1 to 1 is like a horizontal line test. Yes?
What you're saying is if the y repeats.
If the y repeats, thank you. So if you see a y repeating, and they call it 1 to 1, your function is not 1 to 1, and therefore if it's not 1 to 1, forget it. It has no inverse. By the way, this one right here, I just brought this up. Guys, if I plug in 1, I get 5. If I plug in -1, do I get 5 again? You can't let that happen. It's not 1 to 1. It's gonna be a 1 to 1 function, don't forget it. This one, I will tell you ahead of time, and your textbook, he's nice to you. He tells you on the side. Don't worry about it, student. I've already checked it for you. It is a 1 to 1 function. Don't worry about it. It's a 1 to 1 function. So since he's done it, I'll tell you which ones are. So this one is, and therefore there is an answer. There's an inverse. Guys, to find the inverse, 2 steps. Step 1, interchange. Makes this the x, and the x's the y's. Go back to your function, interchange. And then second step, 2 steps, solve for y. And to solve for y here, guys, we're going to do a quick cross multiplication. I don't think you would mind if I did this and write it like that. Just x over 1 and a quick cross multiplication. And then once you solve for y, I see 2 terms containing the y, so let's move that y over from the right to the left. Now, what would you suggest I do at this point if I'm after y? I want to solve for y, not divide.
Isolate.
No, isolate. What are you going to do with that y? You're going to factor it.
Maybe.
You're going to factor it out. You're going to factor it out. And then divide. Divide by what?
By y.
X minus 1. Do I now have the y completely by itself from across the street? So y is equal to 1 over x minus 1. There, we'll make it a stronger statement. There's your inverse of that function. Now, hang on. Hang on. Now, write quickly. Let me go back to the original function. Just at random, I'm going to form an ordered pair. Let me select some number to replace x by at random. Let's try 6. So if I put a 6 in there, guys, I'm going to end up with 7 over 6, I think. In the original function, is it 7 over 6? Now, if this is correct, if this is its inverse, this should give me, turned around, interchange this. If not, we have the wrong inverse. Just at random. So let me see if it is. This would be what? 1 over, I'm replacing x by 7, 6. I want a common denominator, think that 1 is 6 over 6. I'm going to end up with 1 over, guys, is this like what, 6 over 6 or 1 over 6? Is this 6? Did it check? After I turned the ordered pair around, it plugged into my, what I thought was the inverse, it checked? Of course it checked. It checked. Now, David, before I take your question, I don't have the time, you don't have the time. I tested it for only one number. There might be how many numbers in the universe? Infinite. Is it always going to work randomly? Suppose you try 10. Suppose you try square root 2. You just randomly tried a 6, and it worked. It's supposed to work for all numbers. Do I have time to check all numbers? No. Here's what they suggest you do, and they want you to confirm it does always work for all numbers. They want you to do this. This is what they call a check. Did you actually find the correct inverse? They want you to form a composite, back to composite, with your inverse of x, where x could be any number. And first, they want you to form the composite. And you know what this means? It means f of the inverse. Now watch what's going to happen. Watch what's going to happen. This will confirm it always works, not just for my 6 that I randomly chose. Guys, the inverse came out to be in red. The inverse came out to be, we think, that. That's what we think the inverse is. And for the composite, they're asking me to take f of that. Now, what does that mean for me to do? take f of 1 over x minus 1, says go back to your original function right here and replace all those x's by what? 1 over x minus 1. If I do, and I'm on the side toward here, I do it right here, beneath here, this is equal to, when I do it, back here, I'm replacing those x's with 1 over x minus 1, it looks like this. That's what it looks like. You're supposed to take this and put it back here. And then clean it up. Now watch what happens when I clean this up. Guys, we're gonna use a common denominator on top. I'm gonna go quickly. I see 1 over x minus 1. Let me keep it in red. Now, ask me to add 1 to it. Let's think of that 1 as x minus 1 over x minus 1. Let's do 1. Put all that together, run out space there. Put it on the side here. All that's over x minus 1. What's on top here, guys? X. The one's canceled. That's the top part. Now do the same thing down here. And in fact, it was over what? 1 over x minus 1. That's down here. That's this. Put it right here. Now, can someone tell me what's going to happen when I simplify it?
X minus 1.
X minus 1 will cancel. What does that leave? Always x if you have the correct inverse. And what could x be? Anything. Any real number, not just my 6. So these cancel. You simplify it, and you had better end up with an x next Wednesday. If I see you sitting there crying, and it was, what was it? Mr. Parker, what was it? Last semester we had one student who broke down. She actually broke down every, what was quiz? You remember her?
Yeah.
Ooh, she's crying. I don't know what, I'm a professor, I'm not a doctor, I'm not a psychologist. What's wrong with you? Just completely broke down. Right, Park?
Yeah.
You remember?
Yeah.
Okay, so guys, if I see you, no, don't do that.
Oh,
Geez, don't do that. Okay, don't do that. I'll hold it back. Bring in a box of tissues or whatever. But what's going to happen, I hold it back, because if you start checking next Wednesday, you say, oh, professor, you gave me an inverse, I think I found it. And then you go through your little check, here's your check, you gotta do this on it. And you do not get X down here, start crying. That means, nope, your inverse that you think is the inverse is not the inverse. Something happened. Now, I'm not going to do it in both directions. Your textbook suggests have students do it also this way. Turn it around. And you better get an X in it. I usually ask you to do it in one direction, because you have enough to worry about. Dave?
Do you mean, f negative 1, 2 to f?
What's that now? Oh, turn it around.
Yeah.
I'll get it faster. Also turn it around in the other direction. That should also be an X, right?
My original question was, is it sort of a coincidence that the original function and the inverse function is the reciprocal and conjugate?
Not always. Not always. There are some relationships, but not always. Okay? Now, you've got a quiz tonight. And I'm anxious to see what we're going to do on that quiz. Here we go. Before the quiz comes up, this is my planning for tonight. I know and you know this is a rational function. You'll have to graph one for me tonight. Can someone tell me right quickly, let me see if I'm ready for it. See if I'm ready. See if I'm ready. Okay. Can someone tell me what is the x-intercept? Hang on. The x-intercept on the original function, if you were in the process of graphing it tell me just where is the x-intercept on x plus 1 over x?
Negative 1.
Negative 1. You set that numerator equals 0, solve it, negative 1. Now, if this is truly the inverse of that, now tell me what the y-intercept is on this one. Is it negative 1? Or is it negative 1 for the x here? And what is it here? Is the y-intercept negative 1? Did the x and the y turn around?
So you're thinking
Did the x and the y-intercept turn around? Is it what the inverse does? It's turned everything around, right quickly. Where's the vertical asymptote on this? The original function? 0. X is equal to 0. What do you think this will do to that vertical asymptote? It's going to turn it into a horizontal asymptote. So if I ask you where's the horizontal asymptote right here, guys, it's 0. It's y is equal to 0. It's the x-axis. So here's the x-axis for the horizontal. Here's the y-axis for the vertical. It turns everything around from one function to the other. All the intercepts are switched. Vertical turns into horizontal, and then you can graph it from there. And that's the important thing about this idea of an inverse. Guys, making sense? Okay, I'm just checking to see how much more I got to do here. It's beautiful. I hope it's all connecting here tonight for us. Right. Okay. Here we go. Now, step back and look at it. We tried this, we found the inverse. Now let me ask you, erase, stay with this. This is part 3, part D. And I've been blessed with students in this class who, for their exams and quizzes, they're getting top scores. And when I report on Canvas or send you an email and let you know how the class did, you've noticed how many 80 out of 80 scores are made in this class. I've been blessed. 80 out of 80, 80 out of 80. Maybe 6, 7, 8 students. And then all of a sudden I tell you how many A's I have, and 12 A's. That's unheard of. So this is going to be something else here. I want for you guys to maintain all this. I would change something here in the given. That's said. Great class here. We're going to be f of x is equal to x squared. Find its inverse. Okay, I think I heard somebody say it's Samantha. There is none. Everybody discuss that. Sketch in your mind, x squared is a parabola. It would not pass the horizontal line test, has none. But then all of a sudden you go to grad school, or in fact I think in your textbook they did this. They say, sure, let's go back and modify this a little bit. Let's just look at this. Now will that make it 1-to-1 subscription? If they add that constraint restriction, just look at the part of the parabola to the right of 0. That's what the x squared and 0 means. So now, Aiden, I'm thinking about this. Here's the parabola. Would not pass the horizontal line test. But if they say, no, just consider this much of it. In other words, where x is greater than 0, erase this part. And now, have just that piece of that parabola to the right of 0. Now, would that be 1-to-1? Would that pass the horizontal line test? Yeah. And with that, now I can find the inverse. Now I gotta be careful though. To find the inverse with that constraint there, 2 steps. Step 1, go back and interchange. This says y is equal to x squared. Now make it this. And step 2, only 2 steps, solve for y. What would you do to solve for y here? To get the y completely by itself, take the square root. Take the square root. Look at this. This is your inverse of this. If this exists. If this had not been mentioned, there would be no answer. Like Samantha told me, no inverse. This one does have an inverse. Now guys, I think the reason I brought this in, I think we know by now in this class what that graph there looks like. Yeah, square root x. Something like that. Now watch carefully what I'm gonna do here. Can someone tell me? This is y is equal to x squared. The red one is y is equal to radical x. Is there any symmetry between the two? Between the black graph and the red graph, is there any symmetry? Now when I say symmetry, we usually think of reflection across the x-axis. That's not happening here. Reflection across the y-axis, not happening here. But there is a reflection. But it's not across the x, it's not across the y, and we call that symmetry. And I see some hands going up, which I love. Go for it. Oh, almost. Almost. Let's go ahead and slant. Okay, let's put the slant in first. When you say slant, are you telling me maybe, Professor, no reflection across the x, no reflection across the y, maybe if I do it here, make it look reasonable, are you telling me it might do this? Now look at the red and the black. Does it look like across that line there's a reflection of one graph to the other? Yes, no? Now, does anyone think they know what the equation of that simple line, that slant, is? What's its equation, do you think? Give me a guess. X, thank you. Y is equal to X. Oh, by the way, wasn't that X also the check on the inverse to find the composite? And you're supposed to get X? Same thing here. It's supposed to be reflected across X from one graph to the other. Okay? So guys, this thing has an inverse with that restriction now. Now, but before I leave it, this is the inverse. I should point out, what's my domain on the inverse? And the inverse is the red one. What would you say the domain is on the red one? 0 through infinity. Hang on now. Hang on. And what would you say the range, since I'm talking about the red one, what's the range on the red one, the up and down? 0 through infinity, not too exciting. And if I turn those around, it's still not exciting. That should be the domain and range of the original, the black one. Okay, all kinds of things going on with these inverses. Wow, step back and look at it, that is absolutely beautiful. Absolutely beautiful. Some students say, oh, Professor, you're so strict and you want so many homework problems to work out and make sure we're here on time and you can't go to the beach at break, you can't do this. No. Don't do something like that. You go to Math 7, you're not gonna do it. You're not gonna make it. You're not gonna make it. I know some they call these great professors. That Math 7 course is a different course. They expect you to know all this day one. Some of those professors start out with a test day one. And that's it. And it's all pre-calc. They do. Yes?
Who's your favorite Math 7 professor?
Oh, no.
All of them, right?
That would be me if I were teaching it.
Wait, why don't you teach it?
That would be me.
I would take yours. We would all take your Math 7.
Math 7?
Professor, I was signing.
Guys, the only way I would teach a
Yesterday,
Math
I didn't see
7.
you on the list.
The other students have asked me to teach Math 7.
Why not?
The only way I would teach Math 7 is that particular class like your class now. If I could take the same students with me in Math 7. No new students. I don't want to go through the new students coming in. But I don't know them. I don't know their strengths and weaknesses. But I know you. If I could bring the same crowd in, of course, enrollment procedures on this campus, and with 35,000 students we have all together at SMC, this site, other sites, we have 35,000 students. It'd be impossible.
We can make a VIP math 7 Ramsey.
If they would pay me a little extra, yeah, that sounds really good. Okay, guys, that's a good thing there. Part 3, part 4. If I can get all this done, I think we are going to do it. Okay, part 4, look at inverses. See if I'm ready. Oh, I am, here we go. Given, or I do inverses all together. Try one that looks like this. 3x subtract 1 over x plus 4. Like find this. It's inverse. Now don't let me throw something on the quiz next Wednesday and all of a sudden you go walk out and start crying. Because some of you may start talking about the quiz and you'll say, oh, professor threw one at us here. That's not possible. So guys, I must place on the side here this description. In other words, it would pass the horizontal line test. If that's not given, be careful. You have to decide yourself whether it's 1-to-1. And we pass the horizontal line test. But I usually, like the textbook does, they tell us it is 1-to-1. That means it will work. Guys, to find the inverse of this, there's only 2 steps, which I love. Step 1, you interchange. Makes this the x, this the y. Now think of that x as x over 1 for a reason. And then solve for y. I would suggest you cross multiply. So guys, in that direction, I see an xy plus 4x. In the other direction, cross multiplication, merely 3y subtract 1. No problem there. And then once in step 2, to finish up, solve for y. Get the y's by themselves and solve for y. Guys, I'm going to move this 3y over. So the terms that contain the y will be together. And move that 4x to the other side and make it look like that. Try to solve for y. Now what can I do on the left there?
Factor out the y.
Thank you, factor out the y, that's why I did that. X subtract 3, negative 1 subtract 4x, it's going to be a crazy one here, divide by x subtract 3. Let's cancel out. To make this a stronger statement, this is your inverse. It is negative 1 subtract 4x, I hope I have no mistake, over x subtract 3. Done. Now, have I checked it yet? No. We'll check it next. Now, see students looking, I hope all the signs are correct. Anyone follow me? Are we okay with the signs and also? Okay. Now, if I check it, that means form a composite, and you better get X. If not, this is not the inverse. You made a mistake. We'll check this shortly. Tonight, it's coming up, the quiz is coming up shortly for you. Can anyone tell me, right quickly? Oh, this is going to be cute. Hang on. Yes. Where would the vertical asymptote, oh, this is a rational function. It would be located at negative 4. The inverse should turn that vertical asymptote into a horizontal asymptote. Now, take a quick look here. Tell me what you think the horizontal asymptotes, turn around again, is here. The horizontal. Do the x's match up? Do these terms match up?
Negative 1.
What's negative 4? Negative 4 is the coefficient. We rewrite it like this. It's out of order. It looks like that. Right? And when I check out the degrees, the highest exponent, which is the easiest case ever, if they match up, is it merely these coefficients? Is that negative 4? Does that agree with the vertical back there? So the vertical is turned into a horizontal. Right quickly, can someone tell me where is the x-intercept on the original? 1/3. Got to know that tonight. 1/3. The inverse should turn that x-intercept into a y-intercept. So let's go to the inverse and replace x by 0. Do I get negative 1/3 again? And I've marked this thing up a little bit
Yeah,
here.
you do.
Do I? I turn this around a little bit. Replace x by, I got what, negative 1 over a negative 3, that's a 1/3? Is that a 1/3? Did I think I had a 1/3 back here? So turn the x-intercept into the y-intercept. It's flipping everything over. It's interchanging, even on my rational function. Now, will this work for all numbers? Well, this is where you guys show this composite. I'm going to ask you to show it in one direction. If it works, we have the correct inverse. Let's find for a check. For the composite, do mine like this, and I had better get for an answer X. If not, I cannot accept that blocked off inverse. Here we go, guys. It says f of, if you don't mind, put the inverse in red. I'll turn it around a little bit. Negative 1 subtract 4x over x subtract 3. That's f of the inverse. Which means, bear with me, you have to go all the way back here. That's your f function. And replace all those x's with red. Put the red in there. So it's going to be 3 times. There goes the red. Over this. Move that up. And back there, I think what? Subtract 1. Back to the beginning, the x on the denominator, replace it on the red. Doesn't cancel yet. And then, what was that, plus, what was it, plus? Plus 4. Now to me, as an instructor, we did what they said to do, but even as much math as I know, that looks scary, as you know what? Because, Aiden, all of this mess when I clean it up had better come out to be just merely x. Now that looks like it will never become just x, just an answer x. If it doesn't, we have the wrong inverse. You guys gotta clean this up. Grad school, here we come. Okay, guys, my goodness, I don't know how. What would you suggest I even do right here in terms of cleaning this up? Multiply by 3.
Yeah.
Let's think that 3 is 3 over 1. We're just multiplying the top, the numerator, by 3. That's a negative 3, subtract 12x. Just the top. Then 1 times x minus 3, that stays the same. There. Now, I do see there's a minus 1 up there, which is calling for a common denominator. So let's go ahead and write that 1 on the end as, let me make sure everything's correct here, as what, guys? Minus, hang on 1 second. Minus x, yeah, gotcha. Okay, negative 3 plus 12x over x minus 3. Well, we got that, and minus 1, gotcha. And we're going to think of that as what? X minus 3 over x minus 3.
Yeah.
There we go. You put markers. Now, we'll come back to that. Whew. Downstairs, we need to write my denominator. That's 4 with a common denominator of x. Subtract 3, boy, I can hardly see that right there. Okay. Guys, what does that look like on the end? Help me out. I'm trying to.
X minus 12 over x minus 3.
Okay, like what? 4x minus 12?
Yes, we have
4x minus 12?
over x minus
That's what I want here. Little algebra. Now, if all that's correct, that's where where I gotta be careful myself. Let's see what's gonna happen. On top, all these can be put together with a common denominator of x minus 3. Be careful. See that negative sign there? That's gonna change these signs. We'll change it to a negative x and a what? Plus 3. Will the 3's cancel?
Yes.
Let's get rid of those. So we end up with a negative 12x, what, minus x? Is that a negative 13x? I think. Negative 13x, really. Okay. Now downstairs, x minus 3 again, a common denominator. And thank goodness there's no minus sign here, it's just plus. Will these cancel? And I end up with negative 1 subtract 12, is that a negative 13? Now, if I clean this up further, I think, please tell me, do we all recognize that those two were definitely canceled? And I'm left with negative 13x over a negative 13. I got a little scared at first, but now those cancel. There's my x. David?
Yes.
I'm saying, based on what I see, we checked it, that this is the inverse of this. Okay. Now, have I, in grad school, seen some of these don't do this? I'm not asking you to do this stuff. I've seen where they ask us to check it in both directions. I checked it with F, circle the inverse, and all of a sudden, we do this in the other order, and we're supposed to get x again. And all of a sudden, some of those functions we had in grad school, we didn't. It worked in one direction, didn't work in the other. You don't have to worry about those functions. If I came in and showed it to you, you'd be scared. No, we're going to just stick with these. That'll work for sure for us. We're not going to go to grad school yet. Yeah.
Okay, I know we don't have to worry about it, but could you briefly summarize why that would be?
It depends on the function. You've never seen a function that I'm thinking about here that would do that. Okay? But it might be possible. Guys, anything else? I'm watching my time here carefully. I'm doing well. As you're instructor, I'm doing well. Yeah. You are correct. If you get X, that says your work is correct. Now, have I seen students in all the years I've scored papers from East Coast to West Coast, have I seen students just make it X? I have. But I think students know who I am now, and they know, no, man, no. They just go ahead and put it down and say, whoop, X, I got it.
Did it in my time.
And then all of a sudden they get their paper back the next day, maybe, you know, 0. 0. Who on earth of those 300 students in the auditorium would think to do that? Wow. But sometimes students will think to do things. They gotta be careful. Okay. Guys, any concerns here? Now, last thing I want to do before we take that 10-minute break is, I'm glad we did this, because chapter 4 is closing down here pretty soon. Looks like I'm gonna be closing down right here pretty soon. Okay. Guys, just a quick thing, and then I'm gonna talk to you a little bit before we take the break. Just a few seconds here. Let's call this part 5. When you get back to the break, they now move us into, in chapter 4, something known as, here comes another function, as if you guys don't have enough functions to worry about. Use quadratic functions, polynomial functions, rational functions tonight in the quiz. Chapter 5 will be trig functions, absolute value functions. Oh my goodness, all those functions. Here's another one. They start out with this exponential function. Now, I want to give you the brief definition. In and talk to you, and then we'll take a break. Exponential function, as if we don't have enough functions to worry about. But at least this one, the wording itself gives me a hint. Something on exponent, exponential. Now, your textbook gives a description of, a definition of this. Just 1 second. Here it is. Your textbook decides to write as f of x function is equal to a raised to an exponent of x. That's how brief it looks. A raised to an exponent of x. Because they give me a restriction on a. A is known as the base.
It should not be equal to.
Well, they want a to be greater than 0.
Yeah.
And do not let a be 1. Make that a positive, the base is never going to be negative. But don't let it be 1. What do they say? Don't let it be 1.
Like imaginary?
No, nothing about imaginary. Why would they say a raised to the x, that's an exponential, don't let a be 1. You're raising 1 to a power. It's always 1, it's trivial. So don't let a be 1, it's too trivial. So make sure a is a positive number. Now, when you get back from the break, first tell me, this might bother you. That might bother you. Can I classify that as an exponential function?
Yes.
Can I be clever and put that negative sign out front? Do I still have 2 raised to the x? Now, can anyone tell me, after we get back from the break, where they start asking me to see what the graph of these things look like? We got a graph to see what an exponential function looks like. Can you tell me what might this negative sign out front tell me that we've done in this class about the graph, when I finally see what it looks like, of an exponential function?
Reflection
Reflection
across.
across
Across the what? X-axis.
x-axis.
Yeah.
It's reflection across the x-axis. Okay? Woo! Now, with that said, absolutely, here we go. Mr. Bart, but to help me a little bit, I'm going to start out with, when they get back from the break, 2 raised to the x. I'm going to make sure it's an exponential function. My base a is greater than 0, it's a 2. And I certainly not 1, it's a 2. And then they want us to sketch it, and we'll sketch it after the break. And Mr. Parks is going to help me with something later on. I think he knows where I'm headed. Where the base may turn into something you see in calculus quite much. So I'm going to start out with a 2 first. Then gradually lead you into what they see in calculus quite much. Guys, with all that said, before we take that break, I think we've got, what, 5 minutes? Oh, beautiful. 5 minutes. I commend you. I've been bragging on you. If I see colleagues, I saw one of my colleagues today, being very honest with you. He has his office close to my office, and we were talking. Professors do talk. We were talking, and I asked him, I said, do you have so-and-so student? I had her in the summer class for the math 2. That was 6 weeks. We did all this and more in 6 weeks. You've got 16 weeks. You've got an 8. They did it in 6. And so I asked, I said, the student, I think, said, this particular math 7 class, how is she doing? And I mentioned the name. Oh, Ramsey, she's doing well. She's doing well. But when I had to report my roster here recently, all professors had to report their rosters as to who's passing at this point, who's not passing. And the school always asks us to do that. So that will allow you to move into Math 7, or they say, no, your professor says, no, you're not quite ready for Math 7 yet. So sometimes you'll try to enroll in Math 7, and if your instructor in Math 2 says at that point your grade average was too low, you weren't recommended, you'd have to crash the class. That's what they do when they ask us at school to do that, which ones are passing, and therefore they will have the right to go ahead and enroll in Math 7. If Professor Ramsey, if you say that student has a 38% average right now, no, I'm not gonna recommend that student is ready for Math 7. They may get a little stronger as when we close down the final exam in this class, but you'd have to crash Math 7. You will not be enrolled. They're not gonna allow you to enroll. School will not allow you to enroll. You guys be careful with that. I've already submitted my rosters. So have some of you guys enrolled in classes already? So if you have enrolled, then Ramsey said you were ready. Okay, and if your enrollment date has not come up yet, you enroll and you go through it, no trouble. The process is perfect for you. Ramsey said you were ready. So you try to enroll and said, oops, red alert, red alert. Your average in Math 2 was not up to par at that point. So you may have to either repeat the class, or maybe you get a little stronger before the class ends, and then go ahead and crash Math 7, see if the Math 7 instructor has room for you in his or her class, okay? But I will tell you, most of my students, a few did not, but most of my students, I recommend move on to Math 7. Guys, we're gonna take a 10-minute break. I got just a little bit more to say.